Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about attacks on Diffie-Hellman algorithm. In our last class, we clearly discussed about the Diffie-Hellman key agreement algorithm. Please watch that class and come back here. Our assumption here is you already have that knowledge. Based on that, explanation is provided here. See, once remember in our last class, we discussed if A and B wants to exchange the key, first they have to generate the P and G value. This is open to all. Any one party can generate the P and G value. It is sent to the other one openly over the internet. And from that, so A is going to generate a random number X. Using that X, it is going to generate the R1 value. R1 is equal to G power X mod P. This R1 value is sent over the internet. Similarly, B is going to generate a random number Y between 0 and P. It is going to develop this value G power Y mod P. This we call it as R2. R2 is sent over the internet. R2 is sent to A, R1 is sent to B. By using R2 and R1, they are going to generate the key. Both are getting the same keys because G is a generator. The key value is G power XY mod P. So G power XY, G power XY. This is what happens in Diffie-Hellman algorithm. So in what way it is going to be possible to attack? If there is an attacker in the middle, he can get the R1 value. By taking the R1 value, if he identifies the X value, then it is possible to attack the key. But identifying X value, given R1 value, identifying the X value is a logarithmic problem, discrete logarithmic problem, which is very difficult to identify because it is an exponential problem. These discussions made in our previous classes. So discrete logarithmic attack is not possible if P is large. How much large it should be? 300 digits, means 1024 bit large value you have to choose. If the P value is like that, then it is not possible. And one more security you have to maintain when you are implementing the Diffie-Hellman is X and Y values, the random number generated is X. Next time if he wants to exchange the key, they should not use the same X and Y value. Keeps on changing the every time, then it will be very, very secured. And the next attack, see, this attack is not possible on Diffie-Hellman. The other attack is possible on Diffie-Hellman. What's this attack? It is very interesting. Man in the middle attack. How this attack is possible? Suppose A and B want to exchange the key. A is going to generate a G power X mod P value. This we call it as R1. R1 is sent over the internet. This R1 is taken by the attacker. In the middle, he is going to take R1. Actually, this R1 should be sent to B, but he is not sending it to B. He will keep that R1. Instead of sending R1 to B, what he is doing is, he is choosing a random number Z and he is generating G power Z mod P. This we call it as R3. This R3 value is sent over to both B and A. So B actually generates R2. This is G power Y mod P. Same as R2 is sent over the internet. The attacker is going to take that R2 value. It will never reach us to A. R1 will not reach to B. R2 will not reach A. The attacker will take both, and instead of that he is sending R3 value. Means that is G power Z mod P value. So both parties, they are thinking that G power Z mod P is the one they have to use, but it is not. So by using G power Z mod P, it is going to generate the key. What key it is going to get? G power ZY mod P. Similarly, it is going to generate the key K is equal to G power ZX mod P. So this X value known to attacker, this Y value known to attacker, not X value, G power X mod P value is known to attacker. This G power Y mod P value is known to attacker. So now he will play the game. Suppose if A sends the data, he is going to use the key G power ZX mod P. The attacker is going to take the data. He knows that he can apply the key, same key, because he knows that the g power x mod p value is there with the attacker. He can generate the key g power zx mod p, and he will decrypt the data and he will resend to B using the key g power zy mod p. Similarly, if B sends the data, the attacker is going to take that data and he is going to resend the data by using the key g power zx mod p. He may modify, he may not modify the data according to his requirement. But both the data are coming, he knows the actual key values and he is going to exchange the keys, exchange the data. This is what we call it as man in the middle attacker. This can be overcome by using our next technique, which we are going to discuss. So this is what the attacks are possible on Diffie Hellman. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.